Okay guys, on today's notes, we're going to talk about how actually do you go from a polynomial equation, okay, something like this, to graphing it, all right, without just plugging in like a million different points. Okay, and on our last video, we kind of talked about the different things that we're going to use to help us graph, all right? Here's kind of a list of them here. We have leading coefficient test to test for end behavior, okay? Or to determine end behavior, I should say. This is the arrows. We have x-intercepts and their multiplicity, y-intercept, symmetry, and the maximum number of turning points that it can have. And we're going to use that to sketch the graph, okay? All right, so let's go through each of these things one at a time, kind of what we talked about on the last video. Okay, leading coefficient test, you guys, this is the arrows. Like, which way do the arrows go? And it's all determined by the following, okay? You look at the degree of the polynomial, and you determine whether it's positive or negative. So this is a positive with an odd degree. And then that kind of goes back to the chart that we made before. So if you guys want to look at the previous notes, and here's that chart that we made, all right? So if I see right here, odd, positive, I know my arrows go down, up. To remember it better, I think of the graph of x to the third, which my arrows go down, up. Okay? So odd, positive, my arrows go down, up. Now you can say it with words, you can say down, up, you could say, we talked about the words you can use, falling, left, rising, right? Okay, but I usually prefer to just draw my arrows. To me, that's like the easier way to do it. Okay, so I know that my arrows go down, up. That's an important part of being able to graph this polynomial. Okay, the next thing is x-intercepts and multiplicity. Now, this is by far the most important part of graphing a polynomial, like by far. Remember that x-intercepts are also called solutions. So how do we find these? We set equal to 0 and solve. Now, we talked about multiplicity last time. We'll go over that again today. But here's how it goes, okay? Say I set this equal to 0. Now, a lot of them will already be factored out for you, but if you see one that's not, we're going to go ahead and factor this. How many of you guys remember how to factor something with 4 terms? You guys remember how to factor something with 4 terms? It's a type of factoring where, let me kind of remind you, we put something down the middle and we do something over here and we do something over here. You guys remember what it's called? Okay, this type of factoring is called grouping. This type of factoring is called grouping. All right, so let's see here. Whoops. Move that back over here. All right. Grouping goes like this, you guys. I say, okay, what can I factor out from here and here? X to the third and 3x squared. I can factor out an x squared. What's left? Well, I have an x there and a 3 there. And then I say, what do I factor out from here and here? Now, whatever sign is right there, whether it's plus or minus, you always factor that out. So I'm going to factor out a negative. And then x and 3, nothing factors out. So if nothing factors out, go ahead and put a 1. Now, if I take out a negative 1 from a negative x, what's left? X, right? And if I take out a negative 1 from a negative 3, what's left? Well, negative 3 divided by negative 1 is plus 3. And so I have, you guys see how these two are matching? That's an important part of grouping. The two things inside the parentheses need to be matching. So I would write those two things as one term. It's almost like I'm doing another GCF. I'm pulling out x plus 3. And then what's left over? So basically, if I took out, say I factored out x plus 3, x plus 3, and I wrote that in the front, what's left over? Do you guys see that x squared minus 1 is left over? Okay, so how does that help me solve? Well, I actually could take this and factor it one more time. because x squared minus 1 is a difference of squares, and it factors to x plus 1, x minus 1. Okay? Now, you could actually solve this without factoring again, because you could take that, set it equal to 0, add 1 over square root both sides. You could do that as well. All right? But typically, we want to factor it all the way down. That's why we went over a lot of like factoring and stuff on the last chapter. You want to get this all the way factored down. Because now, look, these are called, okay, so I'm gonna give you guys some words here. Just a second. All right. Each of these right here in parentheses, those are called factors. Okay? Because when we factor it down, those are called factors, right? Now, when you solve each of those, x equals -3, -1, and +1. These are called solutions. All right? So that's kind of the difference. When they're in parentheses, they're called factors. When you solve them, they're called solutions. Remember, solutions are also x-intercepts. So over here, I can just say x equals -3, -1, 1. Or I can put it like this. -3, 0, -1, 0, 1, 0. Okay, so check it out. It crosses at -3, -1, and 1. Okay, so I'll go and mark those on the graph. I also know, remember from the beginning, that my arrows will go from down to up. Okay? Getting closer to kind of seeing what this graph looks like. Now, one thing that you want to check right here, you guys. A third degree polynomial needs to have 3 solutions. So I'm good to go. Those are my 3 solutions, and they were all real numbers that I can mark on the graph. Okay? They each have a multiplicity of 1 because I just got them each one time. Now, if there's a multiplicity of 1, you don't need to write it. I mean, you could say this one's a multiplicity of 1, multiplicity of 1. All right? Multiplicity of 1 means it's going to cross the axis at that point. That's what a multiplicity of 1 means. Okay, the next thing we're going to do is a y-intercept. Now remember, the y-intercept, it basically just gives me one additional point on the graph. And for the y-intercept, we're going to plug in 0. Okay, so let me kind of go back up to this equation here that I like wrote all over. Okay, and let's go ahead and plug in 0. So when I plug in 0, I get 0 to the third, 3 times 0 squared, minus 0, minus 3. So I get -3. So that's my y-intercept. So it just gives me one additional point on the graph that will kind of help me to graph it. Okay? All right, next, symmetry. Now, symmetry is only helpful if it has symmetry. And this doesn't, okay? In order to have symmetry, let me just remind you, this is from the last video. To have odd symmetry, it has to have all odd exponents. To have even symmetry, that's a 5 by the way, it has to have all even exponents. X to the 0 is constants. All right? Now come back and look at the original problem. Does this problem have odd exponents, all even exponents, or a mix of both? Okay, so hopefully you guys noticed that this had a mix of both odd and even exponents, which means for symmetry it has none. Okay, almost all of the graphs that we look at, almost, like not all, but almost all, have no symmetry. We'll try to look at some that have some symmetry because they're interesting. But okay, and then the last thing, just remember the maximum number of turning points that this has, the max number of turning points is n minus 1. Third degree polynomial, it has to have 3 solutions, but a maximum of 2 turning points. Okay? This is now the fun part. This is where we actually get to draw our line. All right? Start at the left. We know it crosses at each of the x-intercepts, so it's going to cross, 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 and I just have to make sure I go through that point, right? So I go like this. Cross, cross, cross. That was not the best graph. Hold on, let me do that again. Cross, cross, cross. That still wasn't the best, but whatever. Okay, now, is that point necessarily the minimum point? No. What if somebody else drew it like this? Cross, cross, cross. That would still be right. Do we know how high that goes? No, we don't know right now. We'll learn eventually with something that we use called calculus. Will teach us how to find that point right there, but we don't know how high that goes. Do we know how high that goes? No. So let's say somebody else drew this exact same thing and they went like this. And they attached like this and went up, down, up. Are they right? Yeah. Because it's a sketch. I'm only going to be checking at what happens over here. Did you get the arrows correctly? Did you get the y-intercept? That's what I'm looking at. How high does this go? It's whatever you draw. Okay? Because this is a sketch. Now what I like to do is go to Desmos plus 3x squared and check out how close I got, right? So x to the third plus 3x squared minus x minus 3. Check it out, guys. X-intercepts. There we go. -3, -1, and 1. Y-intercept at 0, -3. And my arrows go down and up. And again, like I said, with calculus, eventually we'll get to the point where we can find those maximum and minimums. But that's not something we're going to do right now. All right? Cool, cool. Okay. Let's do a second question. Now, sometimes, especially in order to get more interesting questions, all right, sometimes we have them already factored out. Because if this was all multiplied out together, you guys, it would be really hard for you to factor this out. Okay, now before we start anything, it's kind of good to know what degree polynomial am I working with. Okay, now why do I need to know that? Why do I need to know what the degree is? Well, the degree actually tells us quite a few things. The degree is going to tell us, it helps us with the leading coefficient test, because I need to know if the degree is odd or even. It tells me how many solutions I'm going to have, and the degree -1 is the max turning points. Okay? So the degree of this polynomial is really important. Now, when a polynomial looks like this, it's really easy to see the degree. It's the highest exponent. My degree is 3. Okay? But when it's like this, it's a little bit harder to see when it's factored out. So here's what I want you guys to do. I want you to, just for right now, so don't actually cross this out on your paper, but picture that like that's gone and that's gone. Okay, get rid of the numbers for just a minute. I only want you to look at the x's. All right, so right now I have x to the third on that one. Okay, when I got rid of the 2 right there, I had x squared. And then when I got rid of the 1 right there, I had x. Okay, so you guys tell me, what would this be? X to the what? Remember that when we are multiplying, we add the exponent. So this would be x to the what? Okay, so hopefully you guys said that this would be x to the 1, 2, 3, 4, 5, x to the 6th. Okay? So that means that I have a degree of 6, which tells me a few things. All right? A degree of 6 means, first of all, it's even and it's positive. So that's going to tell me about the arrows. It means that I better have 6 solutions. And it means the maximum turning points is 6 minus 1. I might as well just fill that out now. But the degree tells us a lot of different things. Okay? It tells us how the arrows are going to go. It tells us how many solutions or x-intercepts we need to have. And it tells me the degree -1 tells me the max number of turning points. So let's go back over here. Let's do the arrows real quick. All right. Okay, for my arrows, I'm going to be doing, let's see, it's an even degree and positive. Even positive is up, up. All right. Even positive is up, up. We just kind of need to remember that chart. Whoops, wrong thing here. Okay, so let me go back over here. Even positive, my arrows are up, All right. Okay, now I'm supposed to have 6 solutions. Okay, I need to have 6. All right, let me go back over to this equation. How do we find solutions? We set it equal to 0. Now let me write it over here. You guys, this is already factored out for me. Okay, and so I can solve it. If I let x to the third equal 0, I get x is 0. But you know what? I actually get that 3 times. Okay? It's almost like I don't think you would want to do this, but you could say like x to the third is x times x times x. X plus 2 squared is x plus 2, x plus 2. And then x plus 1 to the first is x plus 1. Okay? So check it out, guys. Look. 1, 2, 3, 4, 5, 6. And so if you were doing it this way, you could go, okay, my solutions are 0, 0, 0, negative 2, negative 2, negative 1. All right? Because it has 6 factors because of all the exponents. It has 6 zeros. Now you can, 6 solutions. You can go ahead and write it out all those many times, or you just know that if it comes from like an x to the third, you get 0 3 times. Okay? Right here when I solve it, I get negative 2, but I get that 2 times. Right here when I solve it, I get negative 1, and I get that 1 time. So here are my x-intercepts. Like, here's how I actually write that up. You could put x equals 0, you could put 0, 0. And again, that has a multiplicity of 3. You could put negative 2, 0, and that has a multiplicity of 2. And then you could put negative 1, 0, and that has a multiplicity of 1. Now, why do those multiplicities matter? Okay, well, when we go on the axis, all right, a multiplicity of 3, actually, yeah. Let's go back and look at the notes from over here. And you guys can keep these notes out. You can write them down because I'm going to ask you some questions. Okay? A multiplicity of 1 will cross the axis. A multiplicity of 2 bounces. And a multiplicity of 3, we call it like a flat cross or like a weird cross where it kind of flattens out as it goes. We don't usually do more than that. So look at that. If you didn't write it down the other day, write it down now because I'm about to ask you some questions about this, okay? All right. Here we go. So what's going to happen at 0, 0? At 0, 0, it has a multiplicity of 3. Is it going to cross, bounce, or flat cross? Okay, so hopefully you guys said that at 0, 0, because it has a multiplicity of 3, it's going to flat cross. Okay, next let's look at negative 2. Negative 2 is right here. Negative 2 has a multiplicity of 2. So what's it going to do there? You can look back at the other chart. Is it going to cross, bounce, or flat cross? This one has a multiplicity of 2. Okay, hopefully you guys said it was going to bounce along that one. It's going to bounce. Okay, then my last one is at negative 1. That's right here. This has a multiplicity of 1. What's it going to do if it has a multiplicity of 1? Okay, good. It's going to do a normal cross. Awesome. All right, now guys, we have our arrows. So let's go ahead and see how this is going to work, okay? All right, so check it out, guys. Here's how we go. We started this arrow, we bounce, we cross, and then we do like a weird little flat cross thing. Okay? And we could go over to Desmos and see if we kind of got it correct, right? So here we go. I put the equation in here already, so my arrows are up, up. And then watch as I go through here. I'm going to bounce, cross, and then that's what a little flat cross looks like, okay? And those are my intercepts, and you can see exactly what happens on each one. All right? Perfect. Okay. So let's go ahead and go to our last question here. Now, this is not factored out just yet, so we need to go ahead and do that once it's time. We're going to start with leading coefficient test, okay? So I'm going to ask you guys a bunch of questions now that we're starting with I'm trying to flip back and forth from decimals to notability. It freezes on me. All right, here we go. Okay. This, now, it's already all, like, multiplied out. And so we can actually just see the degree right here. This has a degree of 4. Okay. So that's an even. So it has an even degree and it's negative. Go consult your chart. Tell me how the arrows would go. All right. So hopefully for even negative, you guys said that your arrows would be down, down. Okay. Okay. It has a degree of 4. How many total solutions does it have to have? If it has a degree of 4, how many total solutions? It has to have 4 total solutions. All right, let's skip down to a minute to maximum number of turning points. What's the maximum number of turning points it could possibly have? It would be 4 minus 1. It could have 3 maximum turning points. All right. Okay, let's go ahead and go through and do my x-intercepts. It's set equal to 0 and solve. Now, when I set this equal to 0, it is not factored out for me, which means I need to do it. But you guys, luckily, I can see here, I can take out a GCF. You guys remember how to do GCF? I can take out a negative x squared from everything. So I get x squared minus 4x plus 4. Remember, you're taking out a negative. All right? You're taking out a negative. And so when you do that, you get all the signs change, right? Okay, let's go ahead and factor this right here. Let me show you guys how I do that. What multiplies to make 4 adds to make negative 4? It's 2 and 2, both negative. Okay, so here's how I'm going to write this. Let me go ahead and write up here. It's negative x squared, and then it's x minus 2, x minus 2. Now, you can either write this all expanded out, which would be an x minus 2, and x minus 2. Or you can write it all together, which would be an x squared and an x minus 2 squared. Either way, do you guys see my 4 solutions? Okay, look, here's my factors right here. 1, 2, 3, 4. So it's going to be 0, 0, 2, 2. All right. If I do it from down here, here's what I get. Okay, don't worry about the negative. The negative's fine, but, you know, because if negative x squared equals 0, I divide by a negative. If x squared equals 0, I get x equals 0, but it has a multiplicity of 2. If x minus 2 squared equals 0, I get x equals 2, also with a multiplicity of 2. You guys, that's my 4 roots right there, okay? That's my 4 roots. So it's 0, 0, 2, 2. And you can write it like that, or you can just say it's x equals 0, and that one has a multiplicity of 2, and it's x equals 2, and that one has a multiplicity of 2. But that adds up to 4 solutions, okay? You get it? Multiplicity 1, 2, multiplicity 1, 2. That's a total of 4. Okay, my y-intercept is plug in 0. So let's go up here. 0 to the 4th is 0. 0 to the 3rd is 0. 0 squared is 0. So my y-intercept is 0, 0. And you know what? A lot of times your x and y-intercept end up being the same thing. All right? Okay, last but not least, does this have symmetry? Well, look, I have even, odd, even. No symmetry. Okay? So here's what I do. All right, 0, 0 has a multiplicity of 2. Will it bounce, or will it cross, or will it flat cross? Multiplicity of 2. Okay, 0, 0 is going to bounce. I'll put like a B to remind me. All right? If it's 2, 0, and it has a multiplicity of 2, is it going to bounce, cross, or flat cross? this one is also going to bounce. So check it out. Bounce, bounce. All right? And then that's what my final graph will look like. Okay? All right, so hopefully you guys kind of understand how to graph the simple parts of polynomials. We'll be working on this a little bit more. All right? Awesome, guys. Have a great day.